reactions of fats and oils. So first reaction is hydrolysis. Fats undergo hydrolysis by aqueous alkali or enzyme called lipase, which yields fatty acids and glycerol. So fats are nothing but these are the triglycerides. So it is contain a glycerol molecule with the fatty acid. So when fatty acids undergo hydrolysis by aqueous alkali or by using the enzyme lipase, that time it will be hydrolyzed to fatty acid and glycerol. So in the first hydrolysis by enzyme lipase, the fatty acid triglyceride, when undergo hydrolysis by the enzyme lipase, first it converted to diglycerides. The diglycerides converted to fatty acid and glycerol. It is a step-by-step process. First triglyceride to diglycerides, diglyceride to fatty acid and glycerol. So next hydrolysis by aqueous alkali. So when glyceraldehyde, when glyceride or fat reacting with the aqueous alkali is nothing but NaOH or KOH. That time they are divided into a glycerol molecule and a soap, nothing but fatty acid. So when fats are undergo hydrolysis in the presence of aqueous alkali, it will be produce a soap or soap solution. This process is called as saponification. The formation of a soap solution by the hydrolysis of fats is called as saponification. Here, a glyceride is there. When a glyceride is reactive with the NaOH, it will be produce the glycerol and soap solution. So, the soap solution is containing the normal formula of soap solution is it is a salts of carboxylic acid. It is a salts of fatty acid, RCOONA. So that is nothing but sodium acetate, like that. Here in the soap solution, we are having non-polar tail and polar head. Nothing but it is a hydrophilic part and the non-polar is nothing but hydrophobic part. The hydrophilic part is due to the COO minus group. So in this way, the hydrolysis will be happen and saponification of the fats are occurring in the presence of aqueous alkali. Next is hydrogenation. The triglycerides are fatty acids which are in unsaturated. So the fatty acids which are having unsaturation, hydrogenation, nothing but addition of hydrogen to the fatty acid. So when the triglycerides of unsaturated fatty acids converted to triglyceride of saturated fatty acids by addition of hydrogen and catalytic reaction. So the catalyst we are using is nickel, platinum, palladium. Nothing but we are adding hydrogen. So when we are adding hydrogen, what happened? The double bond or triple bond they are converted to single bonds. Means nothing but the unsaturated compound is converted to saturated compound. So in the presence of hydrogenation, the unsaturated fatty acids or triglycerides are converted to saturated triglycerides in the presence of a catalytic hydrogenation. The commonly used catalysts are nickel, platinum, palladium. Here we have two types of hydrogenation reactions are there. One is partial hydrogenation, second one is complete hydrogenation. As the name suggests, partial hydrogenation, here only some of the double bonds are hydrogenated while other are left in the same place, resulting a soft and spreadable product we are getting. Suppose if in a compound it is having three double bonds, only one double bond is converted to single bond, remaining are not converted. So entire compound not converted to unsaturated to saturated. Only some double bonds are converted to sigma bonds or single bonds. That is nothing but partial hydrogenation. In complete hydrogenation, it is also called as full hydrogenation. Totally here, the unsaturated triglycerides are unsaturated fatty acids converted to fully saturated fatty acids. fully saturated fatty acids and lead to a lard-like product. Here we are getting a spreadable product. Here we are not getting spreadable product. So here this is the reaction. So this is the triglyceride or triesters of unsaturated fatty acid. So here at the 8th carbon, CH double bond CH is there. Here double bond is there, double bond is there. So how many double bonds are there? 3 double bonds in this structure. So this is a triglyceride. Triglyceride is nothing but a glycerol with the 3 fatty acids. These are unsaturated fatty acids. So how many unsaturations are there? 3 unsaturations are there. So we are reacting with the 3 hydrogen molecules. That time this unsaturated is compounds are converted to saturated. These are the triglycerides, the tri-esters of saturated fatty acids. Saturated fat, some double bonds are present here. So unsaturated fat, some double bonds are present here. This is the saturated fat, no double bonds are there. So this is the example for fully saturated fatty acid or complete hydrogenation reaction. So here also one compound is there. This is the linoleic acid. So this is the some linoleic acid and undergo hydrogenation in the presence of a catalyst. Which one? Nickel. So in general here how many double bonds are there? 2 double bonds are there. 2 unsaturation sites are there. In between the carbon 13 and 12, in the carbon 9 and 10. So this is a linoleic acid. The structure, it is a, what is the nature of linoleic acid? Liquid in nature. This is liquid in nature. When linoleic acid undergo hydrogenation, so first what happened? Limited hydrogenation. That is what? Partial. So only one double bond is converted to single bond. So this is converted to which one? Oleic acid. And then undergo fully saturated. The another double bond also removed. This is called as stearic acid. This is the fully saturated. So what is the nature here? The nature is lard compound, what is solid compound. Here we are getting some smooth or soft product. Here this is the liquid. So as the saturation is increasing, it will be converted to the solid compound. So in this way, the hydrogenation will be happen. Next third one is rancidity. Rancidity or rancidification is the process of complete or incomplete oxidation or hydrolysis of fats and oils when exposed to air or light or moisture or by bacterial action, results in unpleasant taste or odor. In general, when our triglycerides or fats are exposed to any air or light or moisture or any bacterial action, that time there is a chance of formation of a unpleasant taste odor compound due to the hydrolysis. So this process is called as rancidification and this is called as rancidity. In general, especially it is the hydrolysis or auto-oxidation. Because of hydrolysis or oxidation of the fats will be causes the rancidity and it will be produce the unpleasant taste or odor to the our fatty acids. Here, 2 types of reactions may be happen, hydrolysis reaction and auto-oxidation. The first we are discussing hydrolytic reaction. The hydrolytic rancidity refers to the odor that develops when triglycerides hydrolyzed to free fatty acids. Here the triglycerol, nothing but a triglyceride. So when under hydrolytic reaction in the presence of lipase or in the presence of any acid, glycerol or free fatty acid is produced. That time the unpleasant odor or taste we are getting. This reaction of the lipid with water may require a catalyst. So the catalyst we are using is either acid or lipase, leading to the formation of a free fatty acid or glycerol. Nothing but this is a hydrolytic rancidity reaction. Hydrolysis will be happen. Next is oxidative rancidity. The oxidative rancidity is associated with the degradation by oxygen in the air. In air, oxygen will be there. When fatty acids are exposed to the oxygen, auto-oxidation will be happen. The double bonds of unsaturated fatty acids are broken by free radical reaction involving the molecular oxygen. This reaction causes the release of a unpleasant odor or malicious odor, highly volatile aldehydes and ketones. In generally, the fatty acid will be there. So when these fatty acids or fats are having unsaturated bonds, the unsaturated bonds of the fats are reacting with the oxygen by free radical reaction, leads to the triglycerides of fat, or the triglycerides are converted to ketones and aldehydes, which will be produce unpleasant odor. So the unpleasant odor due to the formation of aldehydes and ketones. This is the oxidative rancidity. Last one, drying oil. So when oils undergo dry, so what is happening? So in generally fats are two types are there. So when we give the dry, being the presence of temperature something, what happen? A drying oil or fat when undergo this type of reaction, that time the oil will be converted to a hardened stiff structure, a solid film after a period of exposure to the air. So when we expose it to the dry air, so whatever the oils will be there, solutions, they are converted to one harder stiff product. So this is nothing but drying of oil. The oil hardness through a chemical reaction in which the components cross link by the action of oxygen. So in the oxygen will be the oxygen present in the air react with our oils, and that time a polymerization reaction, a polymer will be a cross-linked product will be formed. So the drying oils are a key component of oil paints and some vanishes. So the drying occurs because of oxygen. When the oxygen will be reacted with the oils, a polymer chain reaction will be happen. That time a cross-linked polymer will be formed. The cross-linker formula will be look like as a hard stiff structure. Now the oils are converted to hard structure. Some commonly used drying oils include linseed oil, tung oil, poppy seed oil, perilla oil and walnut oil. These are oils are all undergo drying. So here we are representing one reaction. The drying or more properly curing of oil is the results of auto-oxidation. The drying of oils occurs because of the oxidation. The addition of oxygen to organic compound and subsequent cross-linkage will be happening. I already told. So when oxygen will be react with our fat or oil, that time a cross-linkage will be reaction will be happen. That time what happen? A polymerase chain reaction will be formed. So here we represented that one. Here, this is our fat in the presence of oxygen. Then what happen? It will be react a cobalt catalyzed drying process. In the presence of cobalt, the drying will be happen. The cross-linking will be. This is the one fatty acid, and this is another fat. This one oil and this another oil. They are forming a one cross-link. So many oils they will be forming one cross-link, and it will be produce a hard structure. So this is the drying of oil. These are the reactions of the fats and oils.